Hello everybody. Today our experiment is buck chopper. Okay, so we're doing this experiment right here. Experiment number 7. Okay, on page 47. MOSFET buck chopper, and we will connect this circuit. This is the circuit which is connected right there. I'll take you there and I will take out everything and reconnect. Okay, so the new stuff that you will see in this experiment is the smoothing inductor and the chopper inverter control unit. Last time we used the thyristor firing unit, and today we're going to use the chopper inverter control unit. And when we use chopper and inverter, means we are using a transistor. So this unit here works with this module right here, which is a MOSFET chopper and inverter. This module right here is used for chopper and inverter. So the new devices that you will see today is the MOSFET chopper and inverter, and that's the main one. The location is right here for it, MOSFET, chopper and inverter. And the smoothing inductor, which is same as the inductor before, but this is a huge smoothing inductor, and the chopper firing unit. So you can see right here, the smoothing inductor, you're gonna use it, it has 2 parts. Okay, if you connect them in series, each one is 0.4, so 0.4 and 0.4 is 0.8. And if you connect them in parallel, that's what we will do in boost. It will be 0.2, so 0.4 parallel 0.4 is 0.2. So in our case, we're gonna connect them in series. Here we're gonna have 2 inputs. We're gonna have we have 2 sources, okay? DC source 1 and DC source 2. One will control the duty cycle, the D that we explained in theory. So I want you to watch the theory lecture before you watch this. And DC source 2 will control the frequency, which is the big T. So this one controls the T on, and this one controls the big T, which is the frequency. Okay, so this one here and this one here. And here, see here, you can see some output. So here, if you have to choose a mode, see nothing right here. So we're gonna choose the second one. Now it's off. We're gonna go down 1 step, and it says PWM, which is pause with modulation, and we explain that in theory. So you need to watch the theory lecture before you start your lab. So here, when I choose the pause with modulation, you can see here, I don't know if you can see it, but you will see the output, it will work. Okay, now there is an output. Okay, so those are the resistive load, you know it, and this is the DC voltmeter, you're okay with it, and this is the current and voltage isolator. So again, this is the circuit right here. So we're gonna go from the source, which is a DC source now, because it's a chopper, so we're gonna go from DC into DC. We will step down. So if we supply 120, for example, here we can supply, this is 50%. I can supply 100 volt. This is 100 volt now, the source, but the output is 50 volt. And I can, with duty cycle, I can increase to almost like 93. That's the maximum that I can get with the maximum duty cycle that I have. With the minimum, I can go down into like 4, 5 volts. I cannot go to 0. Okay, so now I'm gonna leave it in the middle right here for like 50%. So this is the source, 100. Okay, so we'll go from the source, which is 7N DC. We'll go to the inductive, smoothing inductive load, and then we'll go to the MOSFETs. We'll go to MOSFET. One of the MOSFETs, we're gonna use only 1 transistor. And I want you guys, when you do the connection, I want you guys to look at this gate. This is the gate here, the gate. The gate is like letter L, capital L. So make sure when you do the connection, you make this one as a reference. So you go from the inductive to the top of the L, and you go from the bottom of the L into the DC to the DC emitter, and then from the DC emitter into the current isolator, and then from the current isolator into the load. You go to the load, resistive and inductive, which is this and this, and then you go back all the way to neutral, and then you need to connect the D4. We have a diode right here, okay, to protect the transistor. This one here to protect the transistor, because we don't want to have, we don't want a heavy voltage to be here, so it can harm or damage the transistor. So we have to have a release. We have to have a release during the when it's off. When it's open means off. So the release will be through the freewheeling diode. Otherwise, we will have a huge voltage across the transistor, and it will be damaged. Okay, so that's the circuit. I'm gonna go there step by step, and let's do it together now. Okay, let's remove this. Let's go this, and let me take you there, guys. Okay. Okay, here you can see, well, that's what we have. That's the output right here. I can play with the duty cycle. This is the duty cycle. I can increase, and you can see there when I increase the duty cycle. See here that I increase the duty cycle. You see here. That's 75%, guys, as we explained in class. That's 75% duty cycle. Okay. If I go to the left with the duty cycle, and I can make it 25%. See here? That's 25%. See what will be the output voltage? This is the output voltage. It's only like 25%. And the source is 100 volt. So when the duty cycle is 25, that's my output. So when the duty cycle is 50, let me make it 50 here. I'm gonna make the duty cycle 50. See here, this is my source, 100 volt. And this is my output, 50 volt. Let me make the duty cycle 75%. That's 75%. Let me see, this is the source, 100, and this is the output, which is like approximately 75, 74, 73, something like that. Okay? And as I told you, this is the place here, this is the pulse width modulation that you need to choose. Pulse width modulation. Okay? See here, if I change the mode, everything is gone. So I have to put this here back into pulse width modulation. Now we have the output. Okay, so I connect to the oscilloscope the voltage only here, and I connect the synchronization output just to see here. I mean, actually, you're not gonna see. Even if you disconnect, nothing will be affected here. Okay, but it will be moving. Okay, so that's why we need this. So here from the synchronized to this is the synchronized, and that's the control. So now let's stop. Okay, so now I will disconnect. I will stop. Okay, I will turn off. Okay, I will turn off the 24 volt also. And let's see here. I will disconnect. This is the voltage. This is the voltage here. The voltage. By the way, guys, as I told you here, this is it's explained here. You can look at it. Okay, and those sort of values, you know. What I want to say. Okay, this is the voltage, and this is the. So when you do the connection, guys, go all the way here. Do the transistor right here, then the DC current, then the isolator, and then go to the load, and then go back and leave those till the end. The voltage, and the voltage isolator. So I'm going to take out the voltage isolator here. Okay, so now those are out here. Okay, voltage isolator here and the voltage. So voltage isolator, voltage are out. Okay, now I still have now the circuit without the voltage and the voltage isolator. And I can take the circuit right here. Okay, circuit, I'm gonna take it out. Okay. So I'm gonna leave, as we have done before, which is the red for the circuit and the blue for the volt, and the yellow to add values for the resistive and for the inductive values or loads. Okay. Okay. This one here, it's okay. I'll leave it right here. No problem. Okay. This one right here, I'll leave it. Those here, I will leave those. We know this. Okay. This is it gets the commands from the chopper inverter unit into the MOSFET chopper inverter. So it controls the 9 pins here, 1, 2, 3, 4, 5, 6, 7, 8, 9, and this is 9 pins here. Okay, so those are the same pins as before. This one here is the 24 volt, so the MOSFET needs 24 volt to work. I will disconnect this also. Okay, so now I will start. We need to, okay, this one here, I will just take it right here. Okay, so now I'm gonna go from 7. Okay, as I told you guys, you need to look at the transistor right here, and you see make this L as your reference. You go to the top of the L. So I'm gonna go from 7 into I'm gonna use this transistor Q1. Okay, I'm gonna use Q1 right here. Q1. So I'm gonna go, this is the L that I was saying. So you go to the top of the L, okay? And then you go out from the bottom of the L. So I'm gonna go from the bottom of the L, which is the same for the same transistor, from the bottom of the L to the first smoothing. No, I think I should go to the smoothing first. Okay, no problem. I'm gonna go to the smoothing. Sorry, guys. I'm gonna go to the smoothing. Out from the smoothing, that's the first one, to the transistor, and as I told you, to the top of the L. Okay, here to the top of the L, and then from the bottom of the L right here, which is this. Okay, I'm gonna go to the DC current here. Okay, doesn't matter here or here. You kind of flip later if you think you did it wrong. So then you go out from the DC current to the isolator, to the current isolator. So you go to the current isolator, and then you go out here. That's the current isolator, guys. Then you go out from the current isolator here into the resistive load. As I told you guys, we're gonna leave this voltage isolator and the voltage till the end. We'll go to the load. Okay, so here I'm gonna go to the load, then out from the load I'm gonna close the circuit to the end. Okay, I'm gonna go to the end. Okay, what else I need? I need the diode for this diode right here. This diode number 4. Okay, I need to cancel this Q. I need to cancel this Q right here. This Q, I need to cancel it. I need to cancel this Q right here because this is another transistor. All I need from this, I need the diode for. As I told you to, when we have when the switch is open, the inductive will release, and we need a path. So we're gonna have this path, and we'll connect it back here. Okay. No, we forgot. Sorry, guys. We need to before we go. Sorry, guys. We'll leave this. Before we close the circuit, guys, we need to add another inductive, which is this. Okay. Before we close the circuit, we need to add another inductive. So this is resistive and inductive here. So I'm going to go here. And from here, I will close the circuit now. Okay. And then, as I told you, that I'm going to add the diode number 4. And I'm going to connect it here. Okay. What else I have left? I have left the voltages. Okay. So I'm going to go to the load. Cross which load? That's, you see here, guys? It has to be across both. You see here, this wire right here? This one, the connection between the resistive and the inductive. So I need to include both. So I will not touch this wire right here. I will not touch this wire. I'm going to come here to include both. So again, here. So I'm not touching this wire right here. So everything is included. And then just add the voltage isolator. So I'm going to come from the voltage itself here using blue. I'll come from the voltage isolator. And I will add the voltage isolator. Okay. Then what else I need? As I told you here, this one I will not connect the current now. I will connect the current later, but now I will connect it here, ground, and I synchronize the output. I need to synchronize the output there. And what else? I need the yellow one here. It falls all the time, so I want me to go down. Okay, so here I want to cancel this 4 right here. This 4 here is for this one right here, for this transistor 4. So I need to cancel this. So I'm going to ground it. Here I will ground. Okay, ground. So now I will turn on and see what's going on. So here I will turn on this one. It's 80%, as they said. They want it to be 80%, I think. Yeah, it's 80% right here. Okay. I'm gonna tell you about this draw, but let's see what's going on. Oh, okay, this one here I need to turn it on. Okay. And I need to give this one here 24 volt. Okay. And then nothing, because I need to have a pulse width modulation. Okay, on, it has to be on the pulse width modulation. You hear the noise? Now that's what we have here. This one here is the 75%. Okay, I will make it 50%. See here, now it's 50%. You can see half. This is one cycle right here, from here to here. And this is 50% and this is 50%. So T on is 50% in this case. So what I want you to do here in your lab manual, guys, I want you to draw here 50%. I want you to draw 50% and answer the questions. So here, I want you to draw 50%. So you divide the numbers right here and make your T, for example, 4 boxes. And then T on will be 2 boxes and T off will be 2 boxes. So I want you to use this one here, to use this chart in page 50 and draw 50%. And I want you to answer the questions right here. Okay, answer the questions. And here it says, on the chopper inverter control unit, set the DC source 1 control knob so that the duty cycle of the switching control signal is equal to 50%. Okay, and that's what you will get. Actually 50%, it will not, this will not the value. So don't be confused, guys. If it's 50% duty cycle, here 50%. I mean, those kind of questions, you will see them in the assignment that will be uploaded for you in the Blackboard. So if this is 50% and the source is 100%, here, this is the source. What will be the output? Here, see, it's a flipped. You don't see nothing. So I have to stop and then I have to flip. I have to flip the volt here. Okay. So I'm going to give it again here. Okay. So now the source is This is 50%. This is 50%, guys. And the source is 100%. So what will be the output? You can see it right here. Okay, so expect those kind of questions in your assignment. It could be, the question could be 25. So what will be the output? The duty cycle 25% or the duty cycle 40%. So you need to know how to get your answers with the duty cycle. So here, those are the questions. So we want you to go here over all this. And as I told you before, I want you to follow the lecture for the chopper, for the buck chopper before you look at the experiment. And then next page, in page 52, guys, I want you here in this chart, okay, on this figure right here, I want you to draw me 75% with the current. I'm going to show you the current now. With the current, okay? And you need to answer those questions right here, okay? You can do the calculation right here also. Okay. Yeah, okay. This one here is to show you now I'm gonna show you the current right here. Okay, and those are the review questions. Okay, so let's see here when we want to see the current. Okay, so I'm going to take out this. Okay, or I can leave it here, no problem. I can bring another third one, but no problem. I'm going to leave this canceled, which is the fourth, and I'm going to take this. It's moving, start moving, but I will connect. I want to see the current. So here, that's the ground, and here, that's the current. Okay, let's see the current right here. Is it same as what we explained? Are we gonna start this? This is 50%. You guys see this here? As we said in class, as we said in theory class, in theory lecture. See here, we have two cases. We have the case of charging and discharging. Charging, so when the switch is off, closed, sorry, when the switch is closed, means on, the current, the inductor is charging, right? And when it's off, means open, it's discharging. So that's for 50%. Let's change it here into 70%, but we have to stop, let this run and make it 70% here. Increase, that's 70% approximately. Let's stop here and we can see here. You guys see this? That's 70%, and that's the current increasing and then decreasing, increasing, decreasing, and so on. Let's make it 25%, guys. I'm following the dot here, by the way. There's a dot. That's approximately 25%. We're gonna come here, run, stop. This is 25%. I can see it here. It's 25. See here, one box, 2, 3, 4. So that's 25%. And you see here, the current increasing or charging during the duty on, and then goes down, and you see the output here is only 25%. Okay, this is the experiment for the buck. Okay, and just to remind you about the equations, the equation for the V out is V out equals V source times duty cycle. V out equals V source times duty cycle. How to find the duty cycle is the T on over the big T. T on over the big T. And this is the T on here, and the big T starts from here up to here. That's the cycle. Here, the other one, it controls the frequency, this one right here. See here? You see this? See when I increase the frequency? See here, that's the frequency. Means I have a lot of T's now. Okay? I can have a lot, but the duty cycle is still the same. See here, when I play with the frequency, let me just give you this hint right here. I'm gonna make the duty cycle 75. Okay, that's 75. You guys see this? Okay, now I want you guys to see this. Okay. Okay guys, I want you guys to see this. I will increase the duty cycle. It's 75%. I increase the duty cycle, okay? Look at, this is the source, 100, and that's the output, no change. When I play with the frequency, no change. But what's the thing that changes? Look at the current improves. You can see the current here? It's almost straight. You guys see that? So when we increase the frequency, the voltage is not changing. The output voltage is not changing, but the current, we get rid of the ripple of the current. The current will become smoother. The current will become smoother, okay? So I can release, and you can see this. Okay, that's 50%. Can stop. Still even with 50%. When we increase the frequency, it's almost straight. So with increasing the frequency, we improve the current. Okay, and with increasing the duty cycle, we increase the voltage, the output voltage. Okay. Okay, guys. That's the buck converter. See you next experiment.